Welcome to episode 171 of the Civil Engineering Podcast, the first podcast dedicated to helping civil engineering professionals succeed in work and life. In this episode, I'm extremely honored to be talking to Professor Malcolm Chrisp, who is the head of the School of Energy, Infrastructure, and Society at Heriot-Watt University. Joining him today is 5 of his master-level students who explored a possible Celtic Crossing, a floating underwater tunnel connecting Scotland and Northern Ireland. They are Eoin MacDonald, Dan Marek, Joel Meggs, Rory Saunders, and Gavin Mackay. I'm your host for today's episode, Chris Knutson, and I'm a senior program manager and civil engineer designing and delivering major infrastructure programs and projects for defense clients across the UK, US, and the Middle East. And I've got more than 27 years of professional experience in program and project management and the defense infrastructure section, and currently work as a consultant based out of the UK. And I'm really excited to be back here on the Civil Engineering Podcast after a year or so away doing consulting work. And now I'd like to introduce our guest, main guest for this show today, Professor Malcolm Chrisp, who I mentioned earlier is the head of the School of Energy, Infrastructure, and Society at Heriot-Watt University. He leads a team of academics, researchers, and students on campuses in Scotland, Dubai, and Malaysia, tackling key problems identified in the United Nations Sustainable Development Goals, and is a civil engineer working in industry and academia for over 35 years, and we'll include the bios of each of the students in the show notes for the episode. All right, let's dive into this episode of the Civil Engineering Conversation. Again, very excited to be back with you and excited to dive into this topic. All right, now it's time for our Civil Engineering Conversation for the week, and I'm joined with a large group here, and very excited to have the whole team on board here. Professor Chrisp, thanks for you taking the invitation to join on here, and we're looking forward to talking with all of you here on the Civil Engineering Podcast. So welcome.
Yeah, thanks for asking us, Christian. Appreciate it.
Absolutely. Well, let's go ahead and we'll get started, because we have a number of questions here, and I think this should be a very good discussion that we're going to have. So, Professor, it's I guess we'll start off first by allowing you to maybe just tell us a little bit more about this floating tunnel concept, what it is. A lot of our audience is going to be back over on the other side of the pond in the U.S. They may not be familiar with what all the different discussions that are going on. So just, if you could, maybe just orient us to what the project is and give us a little more insight on what this floating tunnel is.
Sure, yeah. Let me just first set the scene. So here at Heriot-Watt University, our graduates need to be future ready. Technologies are changing rapidly. Our students need to be able to deal with that and explore the latest theories and the latest practices. The external landscape is becoming rapidly globally connected, and our students need to deal with that. So our campuses in Scotland, Malaysia, and Dubai need to work together, bringing these multinational teams together to solve problems. And obviously the Sustainable Development Goals from the UN are asking us to connect with people, society, communities. So the projects that we're working on at the minute need to develop these skills in our students, and they need to be able to work for the communities they're designing. This particular project that we're working on this morning, describing this morning, it forms part of the final year for our students studying Masters of Engineering in Civil Engineering and in Structural Engineering. These are fifth-year students, and they're encouraged to build their own independence, selecting their own project areas. So the students this year have come up with a whole range of innovative projects. Some of them are looking at the electrification of our motorway systems to allow in-journey charging of electric vehicles. Some are working on residential property development in flood risk areas as a consequence of climate change. And others are working in sustainable energy, looking at matching offshore wind intermittent supply to intermittent demand of communities. So the team I brought along this morning, the 5 students that are with me, they've been concentrating on the connection, the fixed crossing between Scotland and Northern Ireland, and that's termed the Celtic Crossing. And clearly it's opportunity for business and political development in our region, and the fixed link between the 2 islands would be a potential major investment for the future. So governments, engineers, professions are really keen to find out what's happening. But clearly for us, there's a lot of technical learning around this project. And in this case of the floating tube particularly, there's a lot of new technologies coming into this. Out in Scandinavia, it's been looked at and explored, and our students decided to go off and explore the application of that into the Celtic Crossing. But the key objective is to push the student into areas of knowledge that they haven't previously come into. So they're set up checking processes, working in the same way as professional practice does, setting up professional checking techniques, resourcing their own knowledge, and then, as civil engineers are supposed to do in terms of civil, connecting with the community and then judge the project impact on the communities, both on the island of UK, England, Scotland, Wales, but also on the island of Ireland itself. So really interesting opportunities for the future. And that's the background to the project.
Yeah, no, absolutely. Thank you for laying that out. And you're absolutely correct. What an interesting and innovative project to be able to have your opportunity to use as part of your kind of your capstone project before you all head off into industry. Joel, could you please talk to us a little bit more about the design considerations that you had to take on board for the project, and maybe why did you end up with the utilization and kind of moving towards this submerged floating tube tunnel? I mean, submerged floating tube bridge, because a lot of people are used to hearing about tunnels. Many are going to be familiar with with the channel and some of the other major projects that have been done using TBMs, but not necessarily this submerged floating tube bridge. So could you share a little bit more about insight on how we ended up with that?
Yeah, absolutely. So the major design considerations can really be boiled down to the weather and the depth of the crossing. So the Irish Sea is famously rough with like high waves and very strong winds. Typically the crossing gets down to about 150 meters, but then towards the Scottish side, there's a big trench called Beaufort Dyke, which goes a further 150 meters down. It's also been a munitions dump since the Second World War, so there are quite a few unexploded bombs down there. Yeah. So those are the main sort of drivers towards finding a solution. We originally thought of using floating bridges. They're quite popular in America, but the longest one we found was, I think, 2.5 kilometers and over quite a calm lake. So it wouldn't fit with the rough seas and the almost 40-kilometer crossing we're thinking here. We then moved on to more traditional piers, and it is possible to build foundations that deep. The Troll A platform has a 300-meter long foundation, but it cost, I think, upwards of a few $100 million, and we'd need at least sort of 12. So the cost sort of skyrocketed using traditional bridge techniques. Plus the weather would mean it had to be closed maybe sort of 100 days in a year. So we then started thinking along the lines of the channel tunnel. And we could dig under the ocean, but given the depth of the dike, we'd need to go so far inland to sort of even out the angle of the tunnel. I think you're only allowed sort of a 2 or 3 degree incline just to allow the trains to travel. That it was no longer an ocean crossing. It was sort of halfway into the country, and the length was enormous. So we needed a solution that sort of combined these two, but was better. And over the course of the research, we discovered the SFTBs, mostly in Norway at the moment. But they, I'm hesitant to use the word perfect, but they fit the solution really well. So we can sink them sort of, it's 30 meters from the surface of the water to the top of the tunnel. And that's a large enough distance that any weather, any waves, any ship passing over has basically no effect on the tunnel. And we can have tethers to the bottom of the ocean floor that, there's one in Norway that has, or tethers in Norway that go up to 1 kilometer down. So the 300-meter length is nothing to them. So it worked really well for the crossing. It was quite an accident to stumble across it, but it's a very happy accident.
Okay, yeah, happy accident like that. So Eoin, maybe tell us a little bit more about the history of SFTBs, because this is, I think for a lot of listeners, this might be the first time they've ever even heard of this type of a technique. And then maybe some of the current ongoing international projects. I know Joel just mentioned some work up in Norway, but I'd be curious to know if this type of system is utilized anywhere else outside of Europe.
Yeah, of course. So it's actually been around for quite a long time. It was first patented in the UK actually in 1886 by naval architect and MP Sir James Edward Reed. But it wasn't really thought about again until the 60s, when it was some Norwegian engineers were brought together for a feasibility study. And they managed to design a 1,500-meter crossing in Norway. And it was the kind of first actual thought-out design for an SFTB. But then when it came to the 80s, 4 top contractors in Norway were given funding from the Norwegian Public Roads Administration to design a 1,400-meter long bridge that went 150 meters deep in a fjord. And they were then awarded to create large-scale models of these SFTBs. These were then designed and then constructed, and then research was done to see if there was any overlooked issues or any significant, anything wrong that could happen with them. And there wasn't any issues with the design at all, which was then further confirmed by an independent group of internationally recognized scientists in the 90s. So essentially, there was nothing wrong with the design of SFTBs. They could definitely work. And so that kind of brings us up to today, where in Norway for the E39 at Bjørnafjord, in 2014, it was commissioned for an SFTB to be designed and then possibly constructed. But sadly, that actually lost it to a more traditional floating bridge, I think they went for. But essentially, it got to the point where they were like, yeah, we could definitely construct this. But apart from that, it's mostly just been research gone into SFTBs, okay. Specifically over in China in the Zhongzhou Strait and the Jintang Strait, and also in Europe and Italy as well. There was actually also one point in Indonesia in 2004 where it was actually also going to be constructed. But then once again, I think it was maybe a suspension bridge was chosen over it. So essentially, a lot of the time, because it's such a novel structure, they tend to just go for the more traditional forms of bridges rather than actually using this, even though potentially it can save massive amounts of money, less material, just because they're so unsure about how it would actually perform in reality. They tend to just go back to the sort of normality, which is maybe not the way that we should be thinking about, considering that, yeah, the benefits could be massive, using this design of bridge.
Okay, I appreciate that. No, you're absolutely correct. It's it is a novel approach to an existing problem, and I can see very very easily on the adaptation of any new technology, or in this case, new application could be a little bit difficult in trying to get that sold through over more traditional proven methods that have been used for a long period of time. So thanks for that, Eoin. Dan, let's shift over to you. I'd be curious if you could maybe set out, you've set out, as you were going through this, setting out 2 different towns on either coast. And I'd be curious to hear what was the process behind the decision to curve the SFTB. And we've already talked about Beaufort's Dyke and what that is, but I'd just be kind of curious to hear what was that process and what were some of the other considerations, both geographical, topographical, and other aspects like that led you to determining the alignment as you did.
Absolutely. Thanks for the question, Christian. So I'll start by saying this was kind of very much an iterative process for us. We started off with a number of different options for locations of towns to span. And myself and Rory set out a process of elimination, of determining kind of suitable locations for the SFTB to reach landfall on either coast. The majority of these decisions were based on where there are existing transport networks, but we also wanted to obviously consider the closest, in terms of the shortest distance to cross for obvious reasons. We ended up choosing the Northern Irish town of Lairn and then the southwesterly town of Portpatrick in Scotland for several economic and social factors. We also realized that we couldn't just kind of plonk these stations in the middle of these towns. I believe the total population of Portpatrick is less than 1,000. So it'd be incredibly kind of insensitive to the integrity of the local area to put these kind of large stations in the towns themselves. The towns are kind of therefore both relatively strategically located. For example, Lairn is around half an hour from Belfast in Northern Ireland, which we felt was really, really important to connect to those existing road networks. And then then we also had to consider that there'd be a significant runoff by the time we reached the coast. So as Joel mentioned, off the top of my head, I believe the maximum allowable gradient is around 1.5 degrees for the freight trains. So after a few calcs, we realized that the stations would have to be set back around 5 kilometers from the coast on each side. And then, as you say, we also decided to curve the route on the land to avoid any disruptions to the towns themselves due to tunneling. The curve of the SFTB was very much a product of geographical limitations, but also to kind of reduce the impact from the lateral environmental forces, using an inherent strength of a curved arch to provide that resistance. And as for Beaufort's Dyke, I can't pretend to have any kind of first-hand experience, although I can imagine that would be a very interesting scuba dive. But what we found online, the Dyke is a natural trench between Northern Ireland and Scotland, and it's actually closer to the Scottish side than the Northern Irish side. The Dyke is around 50 kilometers long, stretching north to west, and around 3.5 kilometers wide, considering our kind of 40 kilometers span of total reach. And then, as Joel said, it's around 200 to 300 meters deep in some locations. So we identified the Dyke pretty early on in our project as a kind of significant hurdle to navigate. And what we could with kind of the data available to us to understand more about it, where it was positioned, and what we could do to kind of mitigate any risks involved. And so what we kind of approach this with is kind of sourcing bathymetry data to kind of map out a better idea of where the Dyke is actually kind of located in practice. And then we use this to tweak our route and avoid the deepest parts of the Dyke. What we found actually early on is from this mapping process that a direct route from Lairn to Port Patrick would actually put us directly in line with some of the deepest areas of the Dyke, according to this bathymetry data. And so then this kind of fed back into our decision to curve the SFTB around these deepest locations.
Okay.
In our final report, we actually proposed that if a feasibility study were to be explored further, then some of the next stages should be a kind of full technical survey of this area to get a complete idea of the severity of the risks, where they're located, and so on. And obviously, the outcome of this in situ survey would significantly impact the location of the anchor pile foundations as well.
Okay. All right. No, I appreciate that. And I think what it does is it highlights for listeners that as you go into every project certainly has technical aspects that have to be taken on board. And for civil engineers, those tend to be the normal elements that a lot of engineers will focus on. Specifically will be those technological pieces. But I think with this project, the other piece that gets spelled out is not only the issues of, Professor, as you mentioned, the UN SDGs, but then also taking in the social aspects. What's the impact on the local, the local populace in either one of those locations? And for anyone that's been up in those areas, and for myself, even I grew up in northern Michigan, but I grew up in a very small town. And to think about the fact where you may be in a small town of less than 1,000 people, and all of a sudden now you've got this major infrastructure that's being put in where there's going to be such a heavy burden, it can be pretty overwhelming and it quickly erode the social aspects that are in that area. So I appreciate that. And I think, Gavin, I'm sorry, I looked through here. Yeah, it's, Gavin, this starts to set up the next couple of questions, which really get us into the discussions around, there's technical aspects. But I'd like you to tell us maybe a little bit more about, as we were looking at there's the geographical aspects, we're talking about some of the social aspects. Maybe talk to us a little bit more about the environmental bodies that you've had to interface with and kind of consider from a stakeholder, not only stakeholder management process, which is something that comes up a lot in project management. Let's look at this from a stakeholder engagement. And how do you get those environmental bodies not as pushing against this, but more supportive of it in relation to, as Ian unpacked for us, these different, more maybe traditional construction methods. So can you tell us a little bit more about that and the environmental aspects?
Yeah, I'd love to. Essentially, the tube actually passes through two areas of scientific importance and near a third one, which would be normally a major concern for most projects and was for ours as well. The two of the areas that we passed through were special areas of conservation, which are pretty much tops or places of no-go sort of construction. But so we really had to think about how we would limit how badly we disturb the animals that were located in these sort of areas. We did this through choosing our construction phases and timing them appropriately to complement the migration patterns of the animals that are actually located in the areas. So for example, we chose that we do the construction in the sea areas to limit the number of during the summer, to limit the amount of disturbance, because the animals are generally located there in the winter. And we also chose to put the fans and so the deck on dampeners and put silencers on fans. And furthermore, the stiffness of the tethers used are actually mitigated a lot of the vibrations that would necessarily disturb the animals as well. Largely the bodies that we actually communicated with was SEPA, the Scottish Environment Protection Agency. The representative that we spoke to actually gave us some great advice regarding the areas, to look out for mines, water tables, and what to do with the excess aggregate from that we removed from the boring processes on either side of the tunnel. He really told us that we should focus on the environmental aspects from the beginning, so that we'd actually mitigate any problems that we could foresee in the future. And we really took that to home in making sure that these, we took these into account, all these problems, potential problems.
Okay, yeah, and I can see that this, from an environmental aspect, the planning aspects and feasibility studies that would have to be undertaken would be pretty substantial. So it's good that you started that process early and reaching out to that, which would become a very key stakeholder in the final decisions on this. And related to that, Rory, I'd be interested if maybe you could further go along. So the environmental aspects are going to be very important. Different bodies associated with that would be a very key stakeholders. But I think the other key stakeholders in this are going to be the kind of the national politicians and maybe business, et cetera. Some of the entities that would end up ultimately becoming financiers for ambitious efforts such as this. I'd be interested to hear if you could maybe unpack for us a little bit more about the stakeholder engagement on the political side, and how does that, or how would it affect design? Coming up with different designs that would be able to suit their needs, and more importantly, get their buy-in and their support for both finance and approvals.
Yeah, sure. But within our government setup, we've got different politicians involved. We've got members of the Parliament of Westminster, and then also the local parliaments, the devolved administrations in Holyrood in Scotland. So we spoke to Sammy Wilson, who's the Member of Parliament for East Antrim on the Northern Irish side. He was really helpful. We spoke to him for about an hour one day over an online meeting. We proposed one of our locations to him, and he gave his honest feedback on that. And we used that to then feed that back into the sort of iterative loop that Daniel mentioned. So that changed our location plan. We were thinking of going sort of further south of Larne, and then instead used a site sort of just outside. The site that we'd originally chosen was sort of a even smaller town, and would face a lot of sort of local opposition and environmental restrictions. We spoke to Finlay Carson, the Member of Scottish Parliament for Galloway and West Dumfries. He really highlighted the issue in that area of Scotland, that the roads just aren't up to scratch. They would need a lot of investment already, and if we were to be building a sort of massive infrastructure, as this would be, the roads would need huge levels of investment. So we fed that back into our project, put aside a section that we can't sort of look at all of the roads in detail, given the time restraints on this project. But it was something that we put aside and highlighted that was a major part of any infrastructure project like this would need road networks to it that are adequate. He pointed us in the direction of the A75 and A77 action groups, and we spoke to them through emails. they were less keen on the idea than the politicians. They were quite happy with what they've got now in terms of the ferry and HGVs, haulage crossing, using the ferries. They were sort of more worried about how a change in that ferry industry would affect their jobs. And we wanted to stress that it wouldn't be overnight shutting off the ferry industry. What we're proposing would be an alternative to provide some competition, and potentially in the long run, it would make the ferry industry better, sort of having a bit of competition, and also a better access across the Irish Sea. We tried to speak to the Transport for Scotland. They are very interested in this project, understandably, but they said they're looking into it themselves as part of a UK-wide union connectivity review. That was across the whole of the UK, various issues, one of which is trying to sort of a physical crossing across the Irish Sea. And they were running a call for evidence. We submitted a 10-page report into them, sort of looking at our general findings. And a few weeks later, they asked for our full-page report. So we signed that into them for them to sort of look at and try and sort of almost use us as a stakeholder, and sort of feed that back into their project. Obviously, the general public are a massive part of it as well. And we got some media coverage around Christmas in a few newspapers. We used the online articles for those and looked through the comments sections, which is quite entertaining. Seeing sort of a full range of ideas that people had about the project. But we could generally see there were a few sort of themes that came up, and we made notes of those themes, what real concerns people had about it, and made sure that they were addressed within our project, within the report, just to make sure that the general population that would be the main users of this sort of infrastructure would be happy with what we'd provide.
Okay. Well, I think the key takeaway is that, again, on any especially major infrastructure projects like this, it's the technical aspects are one thing, but the political and the social and the environmental and all these other aspects that come into what makes and what marks a substantial infrastructure project as being successful can often be the make or break point on that project going forward. So I have one last question for each of you, and I'll kind of run through each of you and give you a chance to answer on it. But if you could just kind of let us all know, as you went through this whole process and as it's played out, and you've had some press and this opportunity to interface with different with politicians and different environmental groups and interest groups. What is one thing that you took away from this whole process and this experience that you think is going to be beneficial to you in your engineering career as you move forward? So I'll give you a chance to think about that one, and we'll start first with Eoin.
I think just the fact that it's important to take a holistic view on everything to do with a civil engineering project. So you can't just focus on the structure itself. Every part of it is important. Especially really, really large projects. Communities will be affected, so you have to take that into account, and the external environment will be affected. Just pretty much that everything needs to be taken into account, and everything's just as important as the structure itself. All
right. Yeah, good observation. Joel.
I think my sort of highlight of the project was the stakeholder engagement. That's where I feel like it really made us shine in a way. Like Rory said, we spoke to MPs and MSPs on other sides, and they had some really concrete advice on how to make the project work for their communities. And so it became less of a theory and more of we're working with the communities. How can we use this with them? And that was really useful, I think, to put it in a grounding in the real world.
Yeah, thank you for that. Gavin, how about you?
Yeah, I've got similar thoughts to Eoin and Joel, but on a different note, it was the ability that we actually managed to get so far into this project that was actually quite shocking to me. It was incredibly impressive how far we got along, because usually you couldn't, at the beginning of the term, we couldn't fathom getting nearly as far as where we got to. I mean, we're in the national press and we're now on a renowned podcast, and it's actually incredible how far you can get with a strong team and working well together.
Yeah, no, it's a really, really good point. It's and I think the civil engineering especially is absolutely a team sport. So you're absolutely right on the money on that. Dan, how about yourself? What did you take away from this experience?
I guess I'll have to kind of mirror what the other guys have said. I think what I think we can commend ourselves as a team is kind of our collaborative input. So kind of like each week we got together, did a kind of debrief of what we completed in that week, what we were happy with, what we needed to change. And I think that allowed us to kind of develop our projects in a lot more kind of a positive way, where we could kind of isolate things that we didn't understand, seek out any individuals out there and kind of reach out to them, use a kind of professional network to find out that information that we didn't know. And I think the fact that we were kind of very kind of open to communicating with other stakeholders and individuals who were kind of a lot more well aware of this topic, that allowed us to kind of grow and develop our own kind of ideas. And I think without that, then we wouldn't have got so far. And I think that's definitely something that I'll take going forward.
Okay. All right. Thank you for sharing that with us. And Rory, how about yourself? What's stuck in your mind is pretty noteworthy?
For me, I think it would be sort of how ambitious we've been. When we started in September, we didn't really, I can't, speaking for myself at least, I wouldn't have thought I'd be sat here in, we're now March, still going on a project that finished at the end of the first semester, and talking to a podcast, and to be in sort of the national press, actually speaking to politicians, just for what we started as a university design project, really sort of being ambitious and sort of working on it relentlessly. How far you can go, sort of speaking to people and really engaging with them, sort of picking a topical project that's really relevant, and how interested people are and how people want to know and want to help. Projects like that. I think that's for me sort of what's stuck.
Yeah, absolutely. So, Professor, in your opinion, how do you see that this project has benefited the students? And we've had an opportunity to hear from each of them, and it sounds like this has been an unexpected experience for each one of them. But you've had a chance to work with a lot of students over your career. Just kind of curious, how do you see this as being the benefit to each of these gentlemen?
Yeah, well, I think, as I described before, that there's numbers of groups that we've got working across the whole civil engineering landscape at Heriot-Watt, and many of them have had their own successes. Obviously, the particular group we're talking with this morning, they're working in a world that you yourself, Christine, described was really disruptive for engineers, dealing with a whole range of different factors. These guys are handling complexity. They're not just handling complexity and ambiguity. They're actually thriving on it. You can see there this morning that they're really on top of this. So for me, that was really, really rewarding to see them being able to cope with these things. We put them under massive amounts of pressure and stress, and it's about self-belief. And they've come out the other end really believing in their skill set. Modest and humble as well, but really, really driving forward. So for me, I think the resilience, resourcefulness, the ownership of the project, clearly it's not my project, this is their project. They really understand it. And consequently, I said at the start, we're about making our graduates future ready at Heriot-Watt University. I think these students are clearly future ready to get out into the workplace and make a huge impact. So that's really, really rewarding to see.
Yeah, it would have to be, and I would echo that. I think that having had a chance for just a brief conversation with the group before we even started this podcast, I think they have a bright future if they stay engaged and you bring the teamwork and all these different aspects and this thriving on chaos and figuring out how to be innovative in the work that you're doing. I think you've got a successful career laying ahead of you in consultancy or whichever route you might end up taking. Yeah, Professor, I got one last question for you. What advice would you give and provide with engineers out there that are considering a career in engineering? So this might be aimed at younger university students or those that are still looking to maybe choose a career. What might you share with them to give them some ideas about why they can consider engineering?
Well, I think we're in really exciting times, actually. We described a rapidly changing world. The public really are demanding that we live much more in harmony with the natural environment. We've heard Greta and her fellow youth really concerned about how we actually engage with the planet, and who are really painfully aware of the shortcomings maybe of mankind's historic approach. So now more than ever really is the time for engineers to stand up and really interface. We're at the interface of the global community and environment, and we need to pull that together. Society is really demanding us to do that, and for professional engineers to stand up. I think this is the time. That's what we need to get the message out there to school leavers and to young engineers coming through. So if you are a school leaver passionate about community, passionate about environment and influencing how we design the future of our planet, then engineering has to be a rewarding choice for you as a career. So I think now is the time for engineering to stand up more than ever and make an impact.
Yeah, those are great perspective and great words, and I would agree with you as well. There's opportunity for each of us as civil engineers to make a true difference and impact on life, even if it's just in our local community.
Absolutely.
It's an unlimited opportunity, I think, for each of us, and for you gentlemen as you prepare to depart uni and head off into the real world, as it were. It's very, for me, it's rewarding to have had a chance to spend some time with all of you and hear about this great experience that you've created for yourselves. But the fact that you'll be able to take that into the proverbial real world with a strong understanding of the impact that civil engineers can have when they work as a team and put their heads together. So I wish each of you individually and as a group the best of success as you move off into the next stage of life. And Professor, congratulations to you for one of what sounds like very many teams of highly qualified civil engineers that you've sent off into industry, into other areas, and I applaud you for the level of effort and the work that you put into it. So each of you, congratulations! You're to be commended.
Thanks,
Cheers. Thank you for
Thank you
that.
very much.
Thanks. Well, this, again, I think for everyone that's had a chance to share some time with us today, hopefully you found this as an amazing experience as I did, and the opportunity to speak with all of them. And we'll leave it there on this podcast. I wish each of you the best again, and I suspect that this won't be the last time we hear about this concept for the submerged floating tube bridge. So to each of you, all the best. All right, everyone. So I hope you enjoyed today's episode of the Civil Engineering Podcast. I know I certainly did. I enjoyed talking with Professor Chrisp and each of the students, getting a chance to know them, but more importantly, get a chance to know and learn more about the Celtic Crossing, the project that they did for their senior project, capstone project in university. It reminded me as we were talking with them of a lot of the other projects that were envisioned by civil engineers over 100 years ago, back in the 1800s. Projects that were brought to us by Brunel, Bazalgette, Roebling, Goethals, the Panama Canal, the Brooklyn Bridge, the London sewer system, and much more. It was really inspiring to hear their experience, the experience that these young engineers have, and what they'll have an opportunity to do as they go throughout their career as either consultants, maybe back into academia or whatever it might be that they get involved in. I was extremely inspiring. Also happy to be back hosting the Civil Engineering Podcast. I have, kind of looking towards maybe an opportunity to be able to come back with you more often, and as schedule dictates and as opportunities come up. So again, I really hope you enjoyed today's episode, and you can always, as always, find the show notes from today's interview at civilengineeringpodcast.com. Just look for episode 171. That's civilengineeringpodcast.com. And there you're going to find a summary of everything we talked about. You'll see not only the bios for the 5 students, but you'll be able to get access to some resources, websites, and any of the books that were brought up and mentioned during the episode. So again, thanks for joining me. Thanks for joining our guests. And I wish each of you the best in your civil engineering career.